Hello students, welcome to aimsindia online classes. This is a chemist session. Here we are going to discuss about the chapter chemical bonding. Okay, let us say about the chemical bonding here. First of all, let us go through the interaction part of this chapter. The attractive force which holds any two constrained atoms or ions together is called a chemical bond. Okay, chemical bond means it is the attractive force between the two atoms. Okay, that is called chemical bonding. The attractive force which holds the two constrained atoms or ions together in a molecule is called chemical bond. Nowadays, we come to know around 118 elements, isn't it? Yes, our scientists they have discovered so far around 118 elements. Out of these elements, a very few elements exist in the free state in the nature. Yes, out of these 118, very less number of elements they exist in the free form in the nature. Most of the elements are existing in the combined state. Very few are existing in the free state and most of the remaining are existing in the combined state. This is because of the instability of elements. They are unstable elements, means they are more reactive elements. The reason for this is these elements are not having octet or duplet configuration in their valency shell. The elements with the octet or duplet configuration in their valency shell are being more stable. Like that, very few elements are existing in the nature. Out of these 118, very few elements are having that octet or duplet configuration. We know those elements with this octet or duplet are called as noble elements. But like that noble elements, very few are there. Most of the remaining elements are not having this octet or duplet and hence they are being unstable. So the remaining elements also they will try to attain the stable configuration either by transferring electrons or by sharing electrons between the atoms, and finally they will try to attain the stable electronic configuration, that is octet or duplet. So in that way, the force of attraction between the atoms because of the transferring or sharing of electrons which holds them together is known as chemical bond. So in this trying, as we told, these atoms are not having octet or duplet and hence they are being unstable. So in trying to become stable, they will try to attain stable electronic configuration, that is duplet or octet. In the trying, sometimes some atoms they lose electrons, some they gain electrons, and even some other elements they will share with electrons with the other atoms. By this process, either by losing or gaining or sharing electrons between the atoms, certain forces of attractions are created. These forces of attractions between the atoms because of transferring or sharing of electrons are called as chemical bond. Got it? Based on the way of bond formation, as we told here, different ways are happening. The attainment of octet configuration or duplet configuration by the elements is happened in different ways. That is, one by transferring electrons, other one by sharing of electrons. So because of these different ways, based on the ways of bond formation, these chemical bonds are classified into two types majorly. One of them is a ionic bond, another one is covalent bond. First, let us go through the one of those, that is ionic bond, which is also called as electrovalent bond. Okay, the chemical bond formed between two or more atoms as a result of the transfer of one or more electrons from electropositive element to electronegative atom is called electrovalent bond. Simply to say, the chemical bond formed by the transfer of electrons between two atoms is called electrovalent bond or ionic bond. This ionic bond is also known as polar bond because we are telling this ionic bond is formed by the transfer of electrons from electropositive atom to electronegative atom. So the atom which lost electron will form positive ion, At the same time, the ion which gained electrons, one or more electrons, will form negative ion. In that way, charged particles are formed and between them attractive force is created, and hence this force is also called as polar bond. Okay, see here one example is shown. One atom is giving electron. This we say electropositive atom, and this is accepting that electron. By accepting this electron, it creates negative charge. It creates positive charge. Between these two oppositely charged ions, now attraction occurs. That attractive force we are calling as ionic bond or electrovalent bond. Okay. Let us see an example. Let us see the formation of sodium sulphide. We know sodium atomic number is 11 and its configuration 2, 8, 1. Means it has only one electron in its valence shell, and it will be ready to lose that electron, and it can attain stability by having the nearest noble gas configuration 2, 8. If we see in case of sulfur, we know sulfur atomic number is 16 and it has configuration 2, 8, 6. So if you see for sodium 2, 8, 1, it has only one electron. It is ready to lose one electron, and thus it can become stable with 2, 8 configuration. If we see for sulfur, its configuration is a 2, 8, 6. It means it has 6 valence electrons. So as it is having 6 valence electrons, it is ready to gain 2 more electrons. By that, it becomes 2, 8, 8 configuration, and thus sulfur becomes stable. Okay. When these two atoms approach, when sodium and sulfur combine together, what happens? This sodium is ready to lose this electron. Sulfur is having capacity to accept 2 more electrons. When sodium and combine When sodium combines with sulfur, when sodium and sulfur combine together, sodium forms sodium ion and sulfur forms sulphide ion by gaining 2 electrons. In that way, sodium sulphide is formed. So, two sodium atoms each loses its valence electron and converted into sodium ions with nearest noble gas neon configuration, that is 2, 8. At the same time, sulfur atom gains these 2 electrons which are lost by one from each sodium and converts and achieves the nearest noble gas argon configuration, that is 2, 8, 8. So by that, between these ions, oppositely charged ions, certain attraction occurs which we can call as ionic bond. Okay. So here each sodium losing one electron. So these 2 electrons are gained by sulfur atom. So that all the 3 are getting nearest noble gas configurations. Isn't it? Thus, oppositely charged ions are created. Between these opposite charged ions now, certain force of attraction is created. That force of attraction is called ionic bond or electrovalent bond. Let us see some more examples. The compounds which are having this ionic bond between the oppositely charged ions. See here, sodium chloride, potassium sulfide it is called K2S, and lithium fluoride, potassium chloride, magnesium sulfide, calcium oxide, etc. Generally, you can say simply here, generalized statement between the metals and non-metals. Generally, ionic bond is formed because metals are electropositive. Metals tend to lose electrons. At the same time, if you say non-metals, non-metals are electronegative elements generally. They tend to accept electrons. So when metal and non-metal they combine, immediately electrons will be transferred from metals to non-metals. Hence ionic bonds are formed. See some are shown here. The formation of ionic bond. Potassium losing electrons. Chlorine is gaining those electrons. So between potassium and chlorine, ionic bond is created. If we see so calcium oxide also. calcium has two valence electrons which is ready to lose those two, whereas oxygen is in requirement of two more electrons. When these two are combined, calcium and oxygen, calcium loses two electrons, oxygen gain those two. Okay, in that way, calcium oxide ionic compound will be formed. Right? That's about ionic compounds. The chemical bond formed by the transfer of electrons from one element to another element is called ionic bond or electrovalent bond. Now let us see another kind of chemical bonding, that is covalent bond. A bond formed by the equal contribution and equal sharing of electrons between two or more atoms is known as covalent bond or sharing bond. Here, co represents sharing. Valent or valent means valence electrons. So, the chemical bond formed by the sharing of valence electrons is called covalent bond. Okay. So here, suppose two hydrogen atoms sharing one electron mutually, contributing one electron, and they are sharing these two electrons mutually. By that, both the atoms they are attaining nearest noble gas configuration, that is duplet configuration. Between these two, because of this sharing, certain force of attraction occurs, that is called covalent bond. Let us see another example. Formation of hydrogen. Let us see the same here. Formation of hydrogen molecule. We know the hydrogen atomic number is 1, means it has only one electron in its valence shell. Is it a stable element? No, because as it is having only one shell, if it is having two electrons, then it becomes stable. But hydrogen has only one electron. It requires one more electron to get a duplet configuration like helium. So in the formation of hydrogen molecule, each hydrogen atom contributes one electron and then the pair is shared between two atoms. So when these two hydrogen atoms approach each other, each hydrogen atom contributes one electron. Then how many they become? Two electrons. Then these pair of electrons are shared by both the atoms. Now if you see this hydrogen atom, it has two electrons by sharing. If we see this hydrogen atom, it also has two electrons by sharing. In that way, both the hydrogen atoms acquire stable configuration of helium. Thus, the molecule consists of one single covalent bond because here the force of attraction is created because of the sharing of one pair of electrons between these two hydrogens. Thus, the bond formed is called single covalent bond or just a covalent bond. Okay, covalent bond means the chemical bond formed by the mutual sharing of electrons between the atoms. See here some other molecules which are having covalent bonds in them. We can say these all are covalent compounds. Means in bit here the molecules are formed by the sharing of electrons between the atoms. CH4, which is called commonly methane, NH3 ammonia, carbon dioxide, hydrogen chloride, nitrogen, oxygen. These all are the compounds which are formed by the covalent bond formation. See one of the molecules here, methane molecule. Here carbon has 4 valence electrons. We know to become stable there should be 8 electrons in the valence shell, but it has only 4 electrons. So it requires 4 more electrons. In case of hydrogen, it has only one electron. To become stable, it requires one more electron so that it gets duplet configuration. When this hydrogen and carbon approach each other, four hydrogen atoms contribute one electron from each. At the same time, carbon contributes four electrons, and thus between each carbon and hydrogen, two electrons are shared. Now this hydrogen is getting duplet configuration. In the same way, all the hydrogen atoms they are getting duplet configuration. At the same time, if we observe for carbon, by sharing of 4 pairs of electrons with the hydrogen atoms, it is also getting octet configuration. In this way, with each hydrogen, it is sharing a pair of electrons by contributing one electron with each. So here we can say between carbon and hydrogen, a covalent bond is formed. Here also one covalent bond. Here also one covalent bond. In that way, 4 covalent bonds are formed, one with each hydrogen atom. Thus it is a covalent molecule. And the methane is called covalent compound. Okay. We see one more. Hydrogen chloride formation. We know hydrogen has one valence electron. It requires one more electron to become stable. If you see in case of chlorine, it has 7 valence electrons. It requires one more electron to become stable. When these hydrogen and chlorine approach each other, they are combined. Hydrogen and chlorine both will contribute one electron each. And these two electrons are shared by both the atoms. See here, hydrogen by sharing this mutual pairing of electrons, it is getting 2 electrons. At the same time, chlorine also getting already 7 electrons are there. One more new electron is shared here by the hydrogen. So that it is getting octet configuration. Thus, between these two, by sharing of this pair of electrons, one covalent bond is formed. Now, HCl is called covalent compound. Okay. In that way, the chemical bond formed by the mutual sharing of electrons between the atoms is called covalent bond. In the covalent bond formation, each atom contributes one electron and that pair of electrons are shared by both the atoms. That is called covalent bond formation. Let us see here the modern concept which explains the covalent bond formation. To explain the formation of covalent bond, a modern concept was proposed which is known as the valence bond theory. Because here the covalent bonds are formed between the valence electrons of the atoms. So to explain the same, the formation of covalent bond, a modern concept was proposed which is known as the valence bond theory. Let us see here what are the important postulates from this. This theory was proposed by Hitler and London in 1927 to explain how a covalent bond is formed. Okay, Hitler and London together they have explained this valence bond theory to explain the covalent bond formation in clear way. This theory was extended later by Pauling and Slater in 1931 to make it some more clear. Okay. Now let us see the important points from this valence bond theory. One of them is a covalent bond is formed by overlapping of atomic orbitals of valence shell of the two atoms. So here it is explained that how a covalent bond is formed. A covalent bond is formed by overlapping of atomic orbitals of valence shell of the two atoms. So here before pairing electrons, this pairing of electrons is taking place when two atoms approach each other. So when two atoms approach each other, their valence orbitals or the atomic orbitals overlap each other and hence they pair their electrons. By that, a covalent bond is formed. Only half-filled atomic orbitals, that is orbitals which are having a single electrons, enter into overlapping process. That resulting the bond acquires a pair of electrons with opposite spin. So here we are telling covalent bond is formed by the overlapping of atomic orbitals of the valence shells of two atoms. So those atomic orbitals in the valence shell which are containing single electrons, that means half-filled atomic orbitals, only they participate in this overlapping process and hence result in the covalent bond formation. So once these atomic orbitals overlap each other, those single electrons both become now paired electrons and they acquire opposite spins. Okay. The atoms with half-filled orbitals must come close to one another with their axes in proper direction for overlapping. So the atoms which are having unpaired electrons in their atomic orbitals. So if these two atoms approach each other, then these atomic or half-filled atomic orbitals must come close each other and in the proper axis. Then only they overlap each other and result in the formation of covalent bond. As a result of overlapping, there is maximum electron density somewhere between the two atoms. So by coming close each other at a certain distance, the atomic orbitals of two atoms they overlap. So as a result of overlapping, there is a maximum electron density somewhere between the two atoms. A large part of the bonding force comes into existence from the electrostatic attraction between the nuclei and the accumulated electron cloud between them. So in that way, electron cloud will be accumulated between the two atoms and hence the bond is created. Greater the overlapping, higher is the strength of the chemical and bond formed between them. So if the atomic orbitals overlap to a greater extent, then the covalent bond formed will be stronger bond. The amount of energy released per mole during overlapping is termed as bond energy. We know while bonding or while forming chemical bonds, atoms they lose energy so that they come into least energetic state or more stable state. There, the amount of energy released per 1 mole of atoms during the overlapping is termed as binding energy. The amount of energy released per mole is called binding energy. This energy stabilizes the system. So when the system loses energy, the system becomes more stable. Stability and energy both we can say quite enemies. If energy is lost, that system becomes more stable. If energy is more, that system will be unstable. So here, by the formation of molecules, by the formation of covalent bonds, atoms they lose energy. So the molecules formed will be more stable. Hence, the molecules formed has less energy and consequently more stable than the isolated individual atoms. Okay, atoms are having more energy. Once they form molecules they are losing energy. Means molecules have less energy. So we can say molecules are more stable than individual atoms. Okay, that's about important points from this valence bond theory. Thank you for watching our video. Please subscribe our YouTube channel Aims Today and visit our website aimstoday.in for latest updates on recorded videos.